Hi everyone. So in the previous video, we saw that RNN has vanishing gradient problem, right, or memory problems. Now, how do we solve this memory problem? Now, we are going to learn about two architectures. Of course, we'll just be going through high level so that we can start LSTMs, start LLM architectures as soon as possible, the transformer architecture as soon as possible. But even going through the high level, we'll try to understand LSTMs and GRUs in this particular video, right? So now, have you ever tried reading a very long sentence and forgotten how it started? This is the exact problem that happens with RNN. But this problem is actually solved by LSTMs. Now, how LSTM work is basically, I'll show you with an example over here. You consider this very long sentence that is present, right? The boy who loved painting and lived in a small house near the mountains disappeared last night. Now, if AI forgets the first few words, how will it understand the full meaning, right? So that's where LSTM and GRU helps AI remember important words even in long sentences. Now, the big problem that was there in the RNNs, the vanishing gradient problem, where as the sentence got longer, early words used to get their meanings used to get lost, right? And that's where if I say something like I was born in France, but I moved to the USA, right? Now, by the time it reads USA, it will forget that it was talking about, it has France in reference. And that's a problem for translation, chatbots, and speech recognition, right? Now, let's try to understand how did LSTM solve this kind of problem, right? Of course, we'll again not go through the entire architecture of the LSTM itself because there are a lot of technical videos which are out there to make it understand. And our basic aim or the main aim over here is to basically jog our memory, get to understand the gist of the previous architectures, and then quickly move towards the transformer architecture. So how they did over here is LSTM is nothing but basically RNNs with memory buffers. Now, instead of just passing the information forward, LSTMs also had important word and forget. It had its own gates which used to store important words and forget the unimportant one, right? So there were three gates which were there in LSTM. The first one was the forget gate. This forget gate used to decide that which past words have to be forgotten. Then it had input gate, which decides which new words are important, and then there was an output gate, which decides which word has to be sent forward, right? And if I give you an example, if AI text was there, I was born in France but I moved to USA, then what LSTM would do, the one that we had over here, right? So now if I had the sentence, I was born in France but moved to the USA, what LSTM will do, that it will remember France while predicting the next. So this is how the LSTM made its way through translation, chatbots, and things like speech to text, right? Similarly, there was one more model which was known as GRU. Now, this GRU was actually quite similar to the LSTMs themselves, but GRU had only two gates instead of three gates which were there in LSTMs. So this made GRUs much simpler and faster, and this was very good for small data sets. These were preferred over LSTMs with the data sets which had fewer calculations, right? Where exactly do we use these LSTMs and GRUs, right? Now, these LSTMs and GRUs, you will use them in Google Translate, where it needs long memory for accurate translation. You will use it in something like chatbots and virtual assistants like Siri and Alexa, where memory from the past responses is required. Again, of course, speech to text, where you have something like YouTube subtitles and voice assistant, where you have to convert spoken words into text. And then, of course, you can use it in something like stock market prediction and time series forecasting, right? Where you have to remember the past trends, and based upon the past trends, you need to basically predict the future. So they were very powerful in its own ways, and even today, in spite of transformer models and other models, you will find production grade applications using models like LSTMs and GRUs, right? So LSTMs and GRUs helped AI understand the sequences, but what if we want an AI agent to generate responses and do language translations? In the next episode, we'll explore something which is known as sequence to sequence model, which was the foundation of the AI powered translations. So share it with someone who might like.